Hello friends, today is the second part of the Ethernet video, and at the end of this video you will learn the Ethernet hardware, firmware and software practically to interface your sensors experimental setup to a PC. See, in the earlier video we learned about the theoretical aspects of Ethernet in Ethernet 1. Now in Ethernet 2 we will discuss more practically how do you implement such kind of systems. Now TCP versus UDP. When you connect two devices or two computers over Ethernet, there are two different ways you communicate. You can use TCP protocol or UDP protocol. TCP is a connection protocol, UDP is a connectionless protocol. TCP, you can see that CAMAC, there is an acknowledgement, there is a handshake. If some packet is going to other end, it has to send an acknowledgement to complete it. Whereas in UDP it is like you send and forget. Now HTTP uses TCP to have a reliable communication. You can see that when the clients communicate to a server, the send CAMAC, and after that data is being sent through HTTP GET. Now RTT we discussed in the previous video, the round trip time, the time taken for one end to transmit and to come back. See that in a TCP communication there is a CAMAC acknowledgement mechanism, which I said already. And finally, when you really receive data from one of the servers, let's say yahoo.co.in, through HTML file, it goes through twice RTT. And also the time taken for the data, the more the data, it will take a little more time. Now you can see in the screen the HTTP communication. Again I am saying CAMAC and acknowledgement of data. So it's a totally acknowledged way of communication, hence it takes time. And in an HTTP client communication, now we are going into a layer which is in the application layer, where you send a question, it's like a message, then you get a response. Now there are some response codes associated with the communications. Suppose you are getting a response code of 200, that means okay, everything is fine, got the data. Suppose there is a problem other end, the device is off or whatever, computer is not communicating, I am saying http abcd.com, which doesn't exist, and you might get a message for not for is like not found. Now in a proper communication system while using Ethernet, suppose you are communicating from A to B and B device doesn't exist at all or is kept off. Suppose B is a temperature transmitting device. You are asking what is the temperature from India, and the device is sitting in US, let's see. So it goes through all these things. You send an HTTP GET command. Suppose it goes on sending the packet 16 times, and after 16 times it accepts the failure. So in this case what we are doing is, suppose there is an HTTP drop happening, suppose the response is not coming proper, That means you wait only 3 times. After that you just remove that device permanently from communications, bypasses the device. That means that device IP is noted and no more communication will happen even if you ask it to communicate. This is application layer mechanism which is used to reduce the traffic due to retransmissions. Now, how to design firmware in Ethernet? See, the entire practical example which I am going to give is to measure temperature, create a temperature server which will give you temperature at 192.168.1.133/RPC/ give me the temperature. Such kind of command you are creating in firmware. You are using ARM MBED microcontroller. Let's say that you have to build the server on a chip, on a microcontroller chip. That part will be discussed in a little later, how to design that hardware, but we start with the firmware. So you have to use MBED library. It's an online compiler. So you use certain header files and you use HTTP server class. After that, it's a small little program. This much program is sufficient to create a simple server. Let's say you are now not trying to read the temperature, you are trying to just make on and off an LED in the board. So what you do is you create a server. The IP address will be automatically dynamically assigned from the network, and after that you can say http://192.168.1.33 or whichever IP it is /RPC my LED 4/write1. It will make on the LED. This is the only, this much only the code required for that. Now, how do you design a hardware? When you use LPC1768 chip, it has got the hardware ports for Ethernet, but you have to buy a match jack connector and connect them like this. This is a circuit. You can simply connect a single supply plus 12 volt into the system, or plus 5 volt or 9 volt into the system, and suppose you are giving the voltage input, you are reading from a 0 to 10 volt DC from a temperature meter, commercial temperature meter proportional to the temperature from a sensor. So this device, what it does, it takes the voltage and convert into a Ethernet, the voltage to Ethernet server, something like that. It's like a voltage server, you can say, to read the temperature. So now, just to give some overview about the packet drops which we discussed in the last video. I said when there is a collision, when two devices transmit same time, it waits for a random time which can vary from 0 to 1023 slot time. Slot time is a fixed time and it's a constant time, so that much delay can happen. Which is how much delay will happen, which is not unknown depending on the number of collisions. N is the number of collisions. After 16 times it retransmits, after that gives up. Now coming back to the temperature meter, this is how you design a temperature meter. The PT100 sensor, you can see that it's a small current source which is feeding a current into the sensor, and the voltage is read back into the pin number 15 of the ARM MBED LPC1768, and the match jack connector is connected through 4 wires, TD plus, TD minus, RD plus, RD minus. After that you write the firmware, which is nothing but a server. Now you can even use a sensor with the temperature meter available commercially, and you take a 0 to 10 volt output from there and connect it to the circuit which we just discussed instead of using a current source, and you can connect it to a computer. This is how we have done that. You can see a sensor hanging. From there it goes to select PID 333 temperature meter, 19.5 degree it is showing. That behind that there is a voltage output which is fed into this small little box which has a circuitry which is shown in the earlier page, and this microcontroller circuitry ARM MBED based reads the voltage from the select meter and converts into the temperature and puts it, and it also has a Ethernet port which will connect it to the PC. This is the entire circuit of that. You can see that now you can go into your browser and say 192.168.1.133/RPC. It will show all the variables: temperature 1, temperature 2, temperature 3, temperature 4, temperature 5, etc. Temperature 1 is what we have connected to pin number 15. So when you do this, you can read the value of temperature directly. These are the different lines required to create the firmware. You have to create a float temperature 1. You have to analog input T1 connected to pin number 15. After that, you create RPC variables like this. You have to be worried about temperature 1. So temperature, others are for temperature 2, 3 if you have multiple meters. See, this is how we define the, you can simply creating Ethernet NetIF ETH class where you can define the IP number of the device, what is the network mask, gateway, etc. After that, you can, from the browser, you may be able to execute a command like that, and it will come into this particular microcontroller firmware. After that, you read the value of T1 from voltage. After that, convert into temperature. Here it is 0 to 409 degrees centigrade. You are reading through 0 to 10 volt. So that is it is looking like that. After that, how do you design a software to read this server? That means you have to create an HTTP client through a programming language. So let's say we are using LabView. You can use Qt or any other symbol, Linux, C++ terminal also. So basically, objective is to establish a client server interface in LabView. Now, in order to do this, just give you some idea about client server basics. The basics of everything goes into socket programming. It's a way of connecting two nodes on a network and communicate each other. And you can see that there is a server and there is a client. These are two different. One is a PC, let's say other is this device. So client requests, a server always listens and client requests to listen. After that, there is string being sent from client to the server, and server can send back the message. This is how you can see the upper left window is the server, lower left one is the client. Two different programs. Let's say this is a Linux PC you are taken and you are not using any particular device or anything. So you are running the server and client. There are two different programs. See, you can see on the right hand side, one side you are asking how are you from the client, and it is returning whatever you are typing back into the server. So for this is, you can create the server and client through a C program, but this is running on a PC. Now what we are talking about, an embedded server where the server is implemented in a chip like this, the hardware, and it works like a small PC. But now here you can ask for the temperature from a network, and the first thing what you do is, after creating the server, you ping to that device 192.168.1.133. That means the server is working, and then the microcontroller chip is returning this. After that, in a browser you can try 192.168.1.133/RPC/temp1/read. The temperature will be read. If you do the communication from a client through a LabView, you can see there is a block called HTTP GET, where you simply send http://192.168.1.133/RPC/temp1/read, and this LabView can simply read the data from the device, will return the data and plot it into the and you can plot it to a graph, and you can see how the temperature is fluctuating with respect to time. So you can do same thing in Qt or any other language. I just give you an example through LabView. That's more simpler to create an HTTP client. Now the same thing, if you want to create a client in an IoT, the same device you can use, and you can have a small little Python code which will convert the temperature from 192.168.133 and convert it to a JSON format to be sent to a blue mix or something, and you can see a blue mix screen where the data can be displayed. So for everything you need Ethernet as the basic hardware, and also the firmware stack. How do you implement a TCP/IP stack? That is what is important to be known. An entire topic can be learned through this book. Thank you.